Hello everybody, welcome back. Today we want to look at generics and let's look at what it is we are supposed to cover today. Now, at the end of this session, participants will be in a position to identify the need for generics, look at the advantages and limitations of generics, explain generic class declarations and instantiation, define and describe generic methods, describe the relationship between collections, what we looked at in the previous session, and what it is that we are looking at today. We look at the wildcard argument, describe the use of inheritance with generics, describe the use of legacy code in generics and generics in legacy code. Then we look at something called type inferencing. Let's start. Introduction. Now, genericity is a way by which programmers can specify the type of objects that a class can work with via parameters passed at declaration time and evaluated at compile time. Now, generic types can be compared with functions which are parameterized by type variables and can be instantiated with different type arguments depending on the context. Let's have an overview of what exactly it is that we're talking about. Generics overview. Now, generics in Java code generates one compiled version of a generic class, and the introduction of generics in Java class will help to remove the explicit casting of class object so that we don't get the class cast exception. You remember we dealt with exceptions in session 12 in the previous module. Now, generics will help to remove type inconsistencies during compile time rather than runtime. Generics are added to the Java programming language because they enable 1. Getting more information about the collection's type, keeping track of the type of elements a collection contains, and using casts all over the program. Now, generics allow the programmer to communicate the type of a collection to the compiler so that it can be checked. Okay, we are saying that using generics is safe as during compilation of the program, the compiler consistently checks for the element type of the collection and inserts the correct cast on elements being taken out of the collection. We have this code snippet to illustrate this. We create a linked list called list and instantiate it. We add an integer. Then we have integer num. You can see now what it is that we are doing here. We have a lot of casting. Now, in this code, an instance of the linked list is created. An element of type integer is added to the list. And when retrieving the value from the list, an explicit cast of the element was required. Now, let's look at this when you're using generics. Linked list, then integer list, then new linked list. Now, from Java 8, you don't have to do this. You can just use the diamond operator. Then list.add new integer. Then integer num is equals to list get the element at position 0. Now, you notice that this code is easier to write as compared to the one in the previous slide. Now, in the code, linked list is a generic class which accepts an integer type as a parameter, and the compiler checks for, we are saying the compiler checks for type correctness during compile time. It is not necessary to cast an integer because the compiler will insert the correct cast on elements being retrieved from the list when invoking the get method. Advantages of generics. Now, generics allow flexibility of dynamic binding, and the generic type helps the compiler to check for type correctness of the program at compile time. In generics, the compiler detected errors are less time consuming to fix than runtime errors. And the code reviews are simpler in generics as the ambiguity is less between containers. When using generics, code contains lesser casts as you saw in the previous slides, and thus this helps to improve the readability and robustness of your code. On the other hand, let's look at the disadvantages or limitations of generics. Now, in generics, you cannot create generic constructors, and a local variable cannot be declared where the key value types are different from each other. Okay, let's start by looking at generic classes. A generic class is a mechanism to specify the type relationship between a component type and its object type. And the syntax for declaring a generic class is the same as ordinary class. except that the angle brackets or the diamond operator, the type parameters are declared. Now the declaration of the type parameter follows the class name, and the type parameters are like variables and can have the values as class type, interface type, or any other type variable except primitive type. The class declaration such as list then E denotes class of a generic type. Now the parameter to the generic class integer in an array integer is the class given in the array declaration and is bound at compile time. A generic class can thus generate many types, one for each type of parameter, such as array, tree, array, string, and so on. We'll see this as we tackle the practical bit of it. And the generic class can accept one or more type parameters. Therefore, they are parameterized classes or parameterized types. What we are saying is, when you're creating these classes, you actually pass in the type. Just like the way when you are calling a method, you pass in some parameters. That is why we are calling them parameterized type, classes or parameterized types. Now, the type parameter section of a generic class can introduce several type parameters separated by commas. Let's see how we go about declaring and instantiating these generic classes. Now, to create an instance of the generic class, the new keyword is used along with the class name, except that the type parameter argument is passed between the class name and the parentheses, and the type parameter argument is replaced with the actual type when the object is created from a class. Now, a generic class is shared among its instances, and the syntax to declare this class is given below. So you type in the keyword class, then the name of the class, then the element, then you have the code for that particular class. So we have this public class number list, then the type, private type, then the object, private void, add type value. Then we have some truncated code here, public static void main. So this is the main method beginning program execution. Then you declare the number list, and pass in a string argument here. The name of the object is list obj, and then you instantiate it. Now, the code creates a generic type class declaration with a type variable t that can be used anywhere in the class. Now, to refer to this generic class, a generic type invocation is performed, which replaces t with a value such as string. Now, typically, the type parameter names are single uppercase letters, and the following are the commonly used type parameter names. We have k. K basically, as you saw, denotes the key. T is for type, V for value, N number, E element, and we have S, U, V, and so on. Now, these are basically used when you have several types that you want to use. And we have a code snippet that illustrates how a class can be declared and initialized. We start with the imports. We have the test queue. I hope you looked at the test deck, not the test deck. I hope you looked at the array deck class I told you in the previous session. Please, if you didn't, go have a look at it in the GitHub link I posted. Now, private linked list, the data type, items, new linked list, then the data type, public void enqueue. So we have the enqueue method, data type item, then you call the items add last method, and you pass in the item that you passed in here. Then we have the data type deck, return items dot remove first. Now we are removing the first item. Then we have the isEmpty method, and you know this basically checks whether the particular collection is empty or not. We have the main method beginning program execution, test queue. We pass in a string. The object is called test obj, and we instantiate it here. Then we add hello and Java. Then we call the println method or println method, and we do a cast of test obj deque or deck. Now, if we go back to this slide, you can see this method is actually going to remove the first element in this particular list. This is going to give us the hello. Now, the following code snippet illustrates how an instance of the test queue will accept string as a parameter. So test string. So we are referencing this code here. Now, in the code, a generic class is created that implements the concept of queue and deck on any data type such as integer, string, and double. And the type variable or type parameter data type is used for the argument type and return type of the two methods. Now, type parameters can have any name, and type parameters can be compared to formal parameters in subroutines. The name will be replaced by the actual name when the class will be used to create an instance. Here, data type has been replaced by string within the main method while instantiating the class. And as we mentioned earlier, you can see the output is going to be hello, as that is what was added first to this particular queue. Generic methods. Now, generic methods are defined for a particular method and have the same functionality as the type parameter has for generic classes. They can appear in generic classes as well as non-generic classes, and they can be defined as a method with type parameters. They are best suited for overloaded methods that perform identical operations for different argument types, and they make overloaded methods more compact and easy to read. Think of an add method that accepts a single parameter. One time it's accepting an integer, the next time it's accepting a double, a float, a short. Rather than writing all that code, why don't you just write a generic method to do that? Let me illustrate very quickly. Now, let's look at the code we have here. We have this add method. It's adding two numbers. If you look at what it's doing here, it's accepting two integers. Here it's accepting two floats, and here it's accepting two shorts. And the code basically does the same thing. Instead of writing this, we can create a compact form as we are talking about. Look at this method now that we have here. Public void add nums. So type num1 and type num2. Then we display the sum. Now, I noticed that it's easier to write it this way because now we can use the format specifier, but that is something we have to forgo. We can still write this. It's a bit inconvenient, but you see now we don't have to write all these overloaded versions of the same method. Thus, it makes your work a little bit easier. Now, we move on. Generic methods allow type parameters to make dependencies among the type arguments of a method and its return type, and the return type does not depend on the type parameter or any other argument of the method. This shows that the type argument is being used for polymorphism, and the following code snippet shows the use of a generic method. We have a class number list that accepts type, and we have public type void display. Then this accepts an array of values. Then we use a for each loop to display each of the values. So system.out.printlf values are %s, then the current element. Then we have the main method beginning program execution. We declare an integer array and assign it these numbers that you're seeing here. Then we use the number list class, pass in an integer, and create an object of type list obj. This is the number list class we had earlier on. Then we instantiate it here. Then we invoke this object's display method. Now, this code uses a generic method display that accepts an array parameter as its argument. And the following code snippet demonstrates how to declare a class with two type parameters. So public class test queue data type 1, then data type 2, private final data type 2 num, then private linked list data type 1 items new linked list. So we are declaring an object items and instantiating it here. Then public test queue data type 2, then this dot num is equals to num. So this is the constructor. Then we have the enqueue method that takes the item that you pass in here and adds it as the last item. Then we have the dequeue class, which basically removes the item which was added last. The following code snippet demonstrates how to declare an ungeneric subclass. So public class myTest extends the test queue. So this one now is accepting a string and an integer. Public myTest integer num, then super num, we are calling the parent class constructor. We have the main method beginning program execution. So we declare an object of this class, that is my test class, and instantiate it here. New integer, then we pass in 10, then we enqueue hello and Java. Then now we call the test the queue, and remember that this basically was displaying the last item that was added. So this basically is going to display for us Java. Now the following code snippet demonstrates the creation of the generic subclass. Class myTestQ. So we pass in the data type, and this extends the myTestQ, then the data type. Main method begins program execution. We declare an object of myTestQ. We pass in string. The object is called test, and we instantiate it here. We pass in hello and Java. Then we call the testDeck class. And basically this is going to output for us the Java. Now, declaring generic methods. To create generic methods and constructors, type parameters are declared within the method and constructor signature. Now, the type parameter is specified before the method return type and within angle brackets, and it can be used as argument types, return types, and local variable types in generic method declarations. There can be more than one type of type parameters, each separated by a comma, and these type parameters act as placeholders for actual type arguments data type, which are passed to the method. Now, primitive data types cannot be represented for type parameters. And the following code snippet displays the generic method present in the collections interface. You can have a look at this in the Java doc. Let's switch there very quickly. Now we go to the java.util, then we are looking at this, the collection. So we have the collection interface here. Then we can continue. Feel free to recap. We looked at this in the previous session. Now, in both methods, so we have this, the contains all and the add all. So we are saying in both methods as shown in the code snippet. The contains all and add all, the type parameter T is used only once. For constructors, the type parameter are not declared in the constructor, but in the header that declares the class. The actual type parameters are passed while invoking the constructor. And the following code snippet demonstrates how to declare a generic class containing a generic constructor. So we have this class called stud pair or student pair, and it's accepting two types. The first one is T, the other type is U. Then we have two variables declared here. So the first one will be T, name, then U, roll number. We have the constructor declared here, T, nmobj, U, roll no. Then we do the assignments here. So the current object's name is going to be whatever you pass in here. The current object's roll number is going to be this parameter that is passed in here. Then we have a display name method that returns type T, return name. Then this other one is returning the type U. This one is returning type U, and we can see here it's return roll number. We have the main method beginning program execution, and we declare an object of type stud pair. This one is accepting a string and an integer. The actual object is called stud obj, and we instantiate it here. We pass in John as the name and 2 as the roll number. Then we call this object display name and display number method. Now you can guess what it's going to give. It's actually going to display the student's name John and the student's roll number, that is 2. Accepting generic parameters. Now, a single generic method declaration can be called with arguments of different types, and generic methods can be defined based on the following rules. Number one, each type parameter section includes one or more type parameters separated by a comma. A type parameter is an identifier that specifies a generic type name. A generic method declaration has a type parameter section delimited by angle brackets preceding the method's return type, and the generic method's body should include type parameters that represent only reference types. Please note that we can't use the primitives. Now, the type parameters can be used to declare the return type, and they are placeholders for the types of arguments passed to the generic method. These arguments are called the actual type arguments. Now, we have this code snippet which displays a generic method declaration. So we declare the class. The class is called generic accept return. Then public static element void display array. So we have element array called accept array. Then we display the array elements. We use a for each loop, and we are outputting this courtesy of a printf statement. Then we have a println statement to add a new line. Then we have the main method beginning program execution. We create an array of integer double end character. Integer int array double. We have these numbers added there. Then we do the same for the double array. We have the character array. Then we have Java. Of course, you pass in the single characters. Then we output them. Integer array contains. We call the display array. Then we pass in the integer array. Then the next one, we are basically passing in the double. So double array contains display array. You pass in the double array. Then the last one, we are actually outputting the character array by calling the display array method and passing in this character array object. Now, as you can see here, the display array is a generic method declaration that accepts different types of arguments and displays the contents of that particular array that you pass in. Now, returning generic types. A method can also return a generic data type, and the following code snippet displays a method having generic return type declaration. The name of the class is generic return test. We have a method public static type extends comparable, then type max value display. So this method is accepting three values of the same type value 1, type value 2, and type value 3. Then we declare inside the method tmax value. So we are making the assumption that the first value passed in is the highest. Now, if val2 compare to val1 is greater than 0, we do this comparison. Now, of course, if this is greater than this, it's going to return a value greater than 0. Then basically now we make the second value to be the largest. So we are assigning it to max value. We do the same comparison. We compare the third value to max value. So if it returns a value greater than 0, then of course now the third value is the greatest. Then we return this max value. So the work of this particular method is to accept three values and return the largest among them. That is why we are returning the generic type T. Now we have the main method beginning program execution, and we want to invoke that generic method. Inside the println method, we actually invoke the max value display and pass in 23, 42, and 1. Here it's actually going to return 42. Then we pass in strings. We have apples, oranges, and pineapple, and this is actually going to return pineapple. P is greater than A or O. Now, type inferencing. Type inferencing enables the Java compiler to determine the type of argument that makes the invocation applicable. It analyzes each method invocation and the corresponding declaration to do so, and the inference algorithm determines the following. 1, the type of argument, the type that the result is being returned, and basically, and the last one, the most specific type that works with all of the argument. Now, type inferencing means looking at the values which you are passing in and inferring their types. Like, for example, if I pass in 20, 3, and 4, you can infer that those are integers. If I pass in 20.2, 34.8, you remember the rules that we said the double is the default type in Java. So the inference is going to assume that those are doubles which you have passed in. We continue. Now, the type arguments required to invoke the constructor of a generic class can be replaced with a set of type parameters, that is the diamond symbol, as long as the compiler infers the type arguments from the context. Now, the following code snippet illustrates this. So map list string, my map, new hash map string, then list string. In Java 7, the parameterized type of constructor can be replaced with an empty set of type parameters. Now, this is Java 7 and later editions. The following code snippet illustrates this. So we have this, instead of, if you compare this code here and what we have in this subsequent slide, you notice now we don't have to keep on repeating this code here. Now, in the following code snippet, the compiler generates an unchecked conversion warning. So map string list string my map new hash map. We need to include the diamond operator for everything to work correctly. Java SE 7 and upward supports limited type inferencing for generic instance creation, and the type inference can be used only if the parameterized type of constructor is apparent from the context. And the following code snippet illustrates this. So here we are declaring a list of strings called list and instantiating it as an instance of the ArrayList class. Then we add a. Now, the following statement should fail because add all expects a collection. So list.add all new ArrayList. So this code is not going to compile. The following code snippet will execute, when executed, will compile. So list, now we have this question mark here, and as we'll see later, this basically means unknown extends string list2, so new array list, then list.add all list2. So we are basically adding all the elements in this list2. Now, generic constructors of generic and non-generic classes. Now, constructors can declare their own formal type parameters in both generic and non-generic classes, and the following code snippet will illustrate this. So my class, then, okay, class, my class, X, then type, my class. So the constructor here is accepting parameters of type T. Now, the following code snippet shows an instantiation of the class, this class that we have declared here. So new my class, then here we pass in an integer. Okay, let's explain what is happening in the code snippet. Now, the statement creates an instance of the parameterized type, my class, and the statement specifies the type integer for the formal type parameter X of the generic class, my class X. Now, the constructor for the generic class contains a formal type parameter, T, and the compiler understands the type string for the formal type parameter T of the constructor of this generic class. Now, this is because the actual parameter of the constructor is a string object. The following code snippet is valid for Java, SE 7 and later, and basically will show you how the compiler works. My class, then integer, my object, then new my class, then you pass in an empty string. Now in the code, the compiler understands that now the type integer is for the formal type parameter X of the generic class, my class X, and the type string is for the formal type parameter T of the constructor of the generic class. Okay, now these are some of the features which were added in Java 7. The underscore characters can be added anywhere between digits and in a numerical literal to separate groups of digits in numeric literals. And the string class can be used in the expression of a switch statement. Now, this was not possible in earlier versions. In Java 7, the integral, that is the integer types, can be defined using the binary number system. And in Java 7 and later, the compiler generates a warning at the declaration site of a var_args method or constructor with an unreliable var_args formal parameter. I hope you remember this from session 7 in the previous module when we discussed about methods. Now, the required type arguments can be replaced to invoke the constructor of a generic class with an empty set of type parameters, as long as the compiler is able to infer the type arguments from the context. Now, a single catch block handles many types of exceptions, and users can define specific exception types in the throws clause of a method declaration because the compiler executes accurate analysis of the return what exceptions. We have the try with resources, and we're actually going to see this in session 8 and this should be 9 and 10 when working with databases. We'll actually declare our database connections using a try with resources to reduce the amount of code that we're going to type. Now, we're seeing that the try with resources statement declares one or more resources, which are objects that should be closed after the programs have finished working with them. Also, when working with files, you can use this statement, which we'll be looking at in sessions 5 and 6. Now, objects that implement the java.lang autoclosable interface or the java.io closable interface can be used as a resource, and the statement ensures that each resource is closed at the end of the statement. Now, collections and generics. We want to link what it is that we learned in session 3 and what it is that we are learning in session 4. A collection is an object that manages a group of objects, and collection API depends on generics for its implementation, and the following code snippet illustrates this. We have this class called generic ArrayList example. We have the main method, beginning program execution. We declare a list of integers called part_obj and instantiate it as an array list. Then we call it add method, add 1010, 2020, and 3030. We invoke the println method. So part numbers are as follows. Now, we declare an iterator and use this part_obj's iterator. Okay, we now move to the next section where we have the while, and we are actually checking as long as the value has next. We declare an integer called part number. We assign it the next value. We declare an integer called part number. Part number, this part number here, we call its int value method, and this is assigned to this integer here. Then we display the part number. Now you can see the output of the code given down here. Okay, wildcard with generics. Now, this is just giving us a very rough overview. And what I would like us to do, please open a browser, open your favorite search engine, then type in Java wildcard. Now, I'll open the Java tutorial. I already have it open. There are so many other sites that you can look at. Remember some of the sites we've been discussing in class. So I'll go directly to the Java doc. Give me one moment to switch. Now, the URL is given here. So you can type in this if you are unable to retrieve it via the search engine. You make sure you read this and you understand. It's very, very important because here in your slides, it's just mentioned and not much literature is given. Read this, and you can see we also have something called the bounded wildcards. So read this and make sure you understand. You can look at examples from Tutorials Point, Bildung, and all these other sites that we looked at in class. Let's continue. Exception handling with generics. Now, exceptions provide a reliable mechanism for identifying and responding to error condition. The catch clause presents a try statement. Now, the catch clause present with a try statement checks that the thrown exception matches the given type, and a compiler cannot ensure that the type parameter specified in the catch clause matches the exception of an unknown origin as an exception is thrown and caught at runtime. So remember that the compiler checks your code as you're typing it, but it does not check your code as it is running. So in case anything happens, then that is up to the runtime to catch that particular exception. Now, thus, the catch clause cannot include type variables or wildcard. Now, a subclass of throwable class cannot be made generic, as it is not possible to catch a runtime exception with compile time parameters still intact. Remember what I said previously. Now, in generics, the type variable can be used in the throws clause of the method signature, and the following code snippet displays the use of generic type with exception. We have this interface here called command. We have X, which is extending throwable. Now, public void calculate, and this method is accepting an integer. Now, this is an integer of type of the integer class, not int primitive, okay? And this particular calculate method is throwing an exception of type X. We have this class extest that implements the command interface, and basically this one is throwing an arithmetic exception. Now we have this method called calculate that throws the arithmetic exception, and we have the code to implement this. Now, inheritance with generics. Inheritance is a mechanism to derive new classes or interfaces from existing ones. And object-oriented programming allows classes to inherit commonly used state and behavior from other classes. And classes can extend generic classes and provide values for type parameters or add new type parameters. Now, you remember that a class cannot inherit from parametric type. Two instantiations of the same generic type cannot be used in inheritance. Now, the following code snippet displays the use of generics with inheritance. We have this class called month that accepts a type. Then we have type month object. We have the constructor, and this month is assigned to whatever it is that is passed inside here. You can still use this keyword. Then we return the month object. So we have the getter here, which is returning the month obj. Then a subclass of month that defines the second type parameter called v. So class month array type, so we have type t and type v, and this particular class is extending the month class. So we declare an object, we declare a type v val obj, then we have a constructor there. It's accepting two types. Inside this particular constructor, we invoke the parent constructor and pass the first object. Then the second object, val obj, is going to be assigned what it is that we passed here. We have the getter for the second object. Now, here we actually create an object of the month array, public class, hierarchy test or higher test. We have the main method beginning program execution. Month array, string integer month. Month is equals to new month array. Then value is 99. We invoke the print method and call the month get object. And then we call the println method and invoke the month get obj2. Now in this code, the subclass month array is the concrete instance of the class month, then type. Interoperability with generics. Now, in Java, genericity ensures that the same class file is generated by both legacy and generic versions with some additional information about the types. This is known as binary compatibility, as the legacy class file can be replaced by the generic class file without you having to recompile the code. We have this diagram here to illustrate this. So you have the platform, so can either be the new platform or the old platform. Then we have the legacy code. Now this does not adapt with the platform. We have the new code, which basically adapts with the platform. Now the following code snippet displays the use of legacy code with a legacy client. We have this interface called numstack here. Then inside this num stack, we have three methods. We have the empty, which is returning a boolean. We have the push method, which does not return. We have the retrieve method, which returns an object. Now, class num array stack. Now, this num array stack is the one which is implementing the num stack interface. And we have a variable of type list called list obj. We have a constructor. Then list obj is instantiated as an instance of the array list. Then we override the retrieve method. Object value list obj.remove. So list obj.size -1. Now, what we're actually saying here is that we're removing the last element. Size gives us the size of the array list or list, and -1 gives us the last item. Remember, we always start counting from 0. That's why we are doing -1. Then we return this value that we got from this assignment. The next one is to override the toString method. The toString method is found in the java.lang object. That is what you're overriding. Return stack, then join this with the list obj.toString. Then we declare a client class. We have the main method beginning program execution. We declare an object of type numStack and instantiate it. Then we have a for loop. We declare an integer counter, initialize it to 0. Then we are going to loop as long as this is less than 4. Every time we loop, we post increment. We have stack obj.push, so new integer counter. Now we declare an assertion. So this assertion should be stack.obj to string. So this should be equal stack 0, 1, 2, and 3. Remember, we have 4 elements. So starting at 0, we should go all the way to 3. Now, int top. So top is going to be assigned stack.obj retrieve the current value. So we are going to retrieve the value starting at the top. Then we display that particular value. Generic library with legacy client. Now, in generic code, the classes are accompanied by a type parameter, as we saw earlier. When a generic type like a collection is used without a type parameter, it is called a row type. A value of a parameterized type can be passed to a row type, as parameterized type is a subtype of the row type. Java generates an unchecked conversion warning when a value of row type is passed where a parameterized type is expected. So we have the collection here, we have the row type, and then we have the normal generic code. Now we have some code snippet here, and this is going to display the use of a generic library with a legacy client. So we have the same numStack interface that we had earlier. Then we have the numArrayStack class, which is implementing this interface. We declare a private list object called listObj. We have the constructor here. ListObj is equal to new array list. We have the empty method return listObj.size is equals to 0. Then we have the push method. The push method, basically we are adding an item to the stack. Then we have the retrieve method. Object value is equals to, we remove the last element. You remember I explained this earlier on. We override the toString method. We declare the client class, and the client class has a main method. We declare and instantiate an object of numStack and instantiate it here. So this is the interface. This is the concrete class. Then we have the normal for loop. We have the counter starting at 0, ending at 3, and every time we loop, we post increment this. We're actually using the push method to add items, and we are actually adding the current value of the counter. Then we have this assertion, we discussed this earlier. Then int top is equals to integer stack obj, then we retrieve all these values. Now, when the code is compiled, an unchecked conversion warning is displayed as shown here. So note client.java uses unchecked or unsafe operation. So not recompiled with xlint and checked for details. Now, when the code is compiled using the switch as suggested, then the following message appears. Client.java21. So this is showing us the line number. Unchecked call to add E as a member of the row type java.util.list. List obj.add. So the warning is given here. Now, the code is telling us, this line is telling us that the warning is due to the use of generic method add in the legacy method retrieve. Now, the warning can be turned off by using the switch minus source, that is, this is the switch now, as shown here. So here we are compiling and passing this switch, and we are compiling this particular file. Erasure. Now, what is erasure? When you insert an integer into a list and try to extract a string, it's actually wrong. If you extract an element from a list and by casting it to string, if you try to treat that as a string, you will get the class cast exception. Now, the reason is that generics are implemented by the Java compiler as a front-end conversion called erasure. Now, what erasure does is that it removes all generic type information, and all type information between the angle brackets is actually thrown out. So a parameterized type like list string is basically converted just to a list. So we lose this information. Now, type erasure maintains compatibility with Java libraries and applications which are created before the generics. Now, generics in legacy code, sometimes it may be required to update the library, not immediately but over a period of time. In such a case, the method signatures get changed and consist of the type parameters. The method body will not change, and this change in the method signature can be performed by making minimum changes in the method, or by creating a stub, or by using wrappers. The minimum changes that have to be incorporated are given below. So the first one is adding type parameters to a class or interface declaration, adding type parameters to the class or interface which has been extended or implemented, adding type parameters to the method signatures, adding cast where the return type contains a type parameter. And we have a code snippet to illustrate this. Now, this is the previous code. We have the num stack. Then we have this annotation for suppressing warnings for the unchecked warnings. Now, we have this num array stack element which implements the num stack, this interface here. We have seen this code. You can rewind if you don't remember what we did here. Then we have the empty method overridden here, the push method overridden, and the retrieve method overridden, and also these methods, the empty, push, retrieve, and toString methods are overridden. You can refer to the earlier explanation. We have the legacy client created here. So class, client legacy. We have the main method beginning program execution. We declare and instantiate an object of the num stack interface, but implement it as a concrete class of the num array stack. We have the normal for loop. We declare an integer counter initialized to 0. We loop up to 3, and every time we loop, we post increment. We have the stack object. We call it push method, and basically we create a new integer and pass in the current value of the counter. We make this assertion as we did earlier on, declare an integer called top, and basically we are actually retrieving the integer value of the stack object. Then we display value is, so we write the value at the top, and then we output the stack contains, we display the numbers which are in that particular stack object. Now, using generics in legacy code. Now, a generic library should be created when there is access to source code, and update the entire library source as well as the client code to eliminate potential unchecked warnings. So the following code snippet shows the use of generics in legacy code. we have the NumStack interface. Now here it only has two methods, that is the push and the retrieve method, and this one is returning elements. We have the NumArrayStack, which is implementing this NumStack. We declare a list called listObj. We have the constructor here. Then we override the push and the retrieve methods here. And also the toString method. We declare a generic client, and this generic client has the main method. Now NumStack, so here we declare an object of the interface and we pass in an integer. The object is called stackObj. We instantiate it as an implementation of the NumArrayStack class. We have the same loop we had here, and we add elements to this particular object by calling the push method. We make this assertion, then we display the value is, we display the value at the top, then we display the elements contained in this particular stack object. Now the interface and the implementing class use the type parameter, and the type parameter E replaces the object type from the push and retrieve method signature and method body. Now the appropriate type parameters are added to the client code. We've come to the end of the session. We want to summarize, and this is what we learned. Generics in Java code generate one compiled version of a generic class. Generics help to remove type inconsistencies during compile time rather than at runtime. There are types of wildcards used with a generic, such as the unknown extends type, unknown, then super type, and the question mark simply means unknown. I hope you read, or you will read that in that page I showed you. Now, generic methods are defined for a particular method and have the same functionality as the type parameter have for generic classes. Type parameters are declared within the method and constructor signature when you are either creating the generic methods or the generic constructor. A single generic method declaration can be used with arguments of different types, and a type inference enables the Java compiler to determine the type argument that make the invocation applicable. Thank you, nice time, and God bless.